Good morning. Today's Wednesday. We are reviewing order of operations and replacement value. I know that we did this some last week, but there were certain types of problems that I saw a lot of us kind of had some trouble with. So I wanted to go over those concepts. Most of them focused on either some type of grouping or on exponents. So that's going to be our focus for today. So remember your forms of grouping. Of course, you could have parentheses. You could have brackets and braces, which we didn't have a ton of in our practice, and that didn't seem as much to be the problem. It was things like square root when you have that radical, making sure you understand what is part of that grouping and what is not. Same for absolute value or a fraction as well. With our exponents, so you might have a variable. I'm just going to use a variable to represent any number. It could be squared, or it could be a variable maybe to the fourth power or to the third power. So we need to make sure that we understand what all of that means, because those were the two areas with the grouping and the exponents that we kind of had the toughest time with. So I'm actually going to start by going over some problems that we had with our little classwork page from Tuesday last week. So the first one was question 2 on your paper from last week, and this really was just order of operations. It didn't involve replacement value or really even any grouping. The parentheses in this problem are just showing you basically either they're really just showing you that negative sign in front of those numbers is separated from other stuff. A lot of times you see negative numbers in parentheses. It's not really any of our steps, but we need to go through this problem. So to start out, first thing I would do here, I really just have, this is the same as negative 18 minus negative 5 divided by 3. So the first thing I want to do here is my division step. Ooh. First thing I want to do is my division step. So I'm going to do negative 5 divided by 3. Now this is where it doesn't work out very nicely. If you work that out in your calculator, you would get negative 1.6, and that's 6 repeats, right? And it's really, you can't really show, if you showed me the steps on your paper, you can't really show that line over it. So some people did just this. They wrote that 6 a few times with the 3 dots after it, showing that it continued. Okay, and I would carry down. You don't need the parentheses around that negative 18. Again, it was just because it was a negative number. So I have negative 18 minus negative 1.6 repeating. And the important thing here is that when I have two negatives, or if I'm subtracting a negative like I am right here, that is going to become addition. So subtracting a negative is the same as adding. So this is negative 18 plus 1.6 repeating, right? And if you do that in your calculator, if you could you can type in that 1.6 as much as you can, or if you kind of left it in your calculator from when you did that division problem, it will actually recognize what that repeating decimal is. And if you add that to the negative 18, that would give you, and I'll switch colors back for this last step, that would give you a final answer of negative 16.3 repeating. So some people did that 3 repeatedly to show that it was repeating. Some people, you really couldn't do the bar by typing it in Word. So some people did negative 16 and they realized that 0.3 repeating is a third, so negative 16 and a third. So either of those answers would have been just fine. Up top here, I'm going to write in how most people had it, which was negative 16.3 repeating. And that was a tricky problem. I think maybe it threw some people because of the negative and the repeating decimal, but that is the correct answer. Now going on to question 6 from last week. This had a lot going on here, and I'm going to fix the spelling of exponent. There you go. So this had an exponent, this had a fraction, and it involved square root. So there was a lot of things here that made this a little bit of a tricky problem. Remember, when you're dealing with a fraction, you want to solve the numerator and denominator separately. So in the numerator, I have 3 cubed minus 8 times 9. Now the exponent here tripped up a lot of people. 3 cubed does not mean 3 times 3. 3 cubed means 3 times 3 times 3. So the answer is not 9, and you can use your calculator if you need for this. Even if you have like a calculator on your cell phone, you can a lot of times turn it sideways and then you'll see more buttons. You can use the Desmos calculator, the square or the y the x button is on there. Even think if you're using the one that's on your computer, which is not the one that we're trying to encourage you to use. We want you to use Desmos, but if you go to scientific here, then you'll see some of those other functions, like it says x to the y instead of y to the x, which is I think what it might be on Desmos as well. All right, so if I work that out, 3 cubed is actually going to be 27 minus 8 times 9. At this point, I would multiply before subtracting, right? So this would be 72, and I have 27 minus 72, which would give me a numerator of negative 45. So that's my numerator here. I'm going to kind of do this off to the side. Okay. So my numerator is negative 45. Then I have to solve the denominator. Right, so that is the square root of 121 plus 4. This is where a lot of people had trouble. This plus 4 is not under the radical sign. So I'm not taking the square root of 125. I'm taking the square root of 121. So square root of 121 would be 11 plus 4, and that is 15. So the denominator is 15. So I have negative 45 divided by 15. That part would give me negative 3. And then I'm adding that 10 over here. So I have that negative 3 plus 10. So negative 3 plus 10 would give me a final answer of positive 7. And that's what I would write in the answer blank over here, was positive 7. So again, I wrote up at the top kind of the tricky things in this that tripped a lot of people up. Either that exponent, recognizing that 3 cubed is 27, recognizing how to handle the fraction, which I think we're getting better at, or that square root, and recognizing that the plus 4 is not under the radical sign. All right. Next, I want to do number 7, and this did involve replacement value. This was on the bottom half of your page. So first thing you would actually have to do is substitute in your values. I'm going to work this over to the right because I have more space. So 4 times y here is negative 1. Oops. Negative 1 plus 5 minus, and then n here is 4 to the 4th power. So now I follow my order of operations, of course. So I would do my parentheses first. So I have within the parentheses negative 1 plus 5, which is 4. So I have 4 times 4 minus 4 to the 4th power. There's a lot of 4's going on here. And these two things do not mean the same thing. 4 times 4 is not the same as 4 to the 4th power. So you're not going to end up with an answer of 0. I'm going to do my exponent first because that would come first before multiplying. Again, 4 to the 4th power. If I do this over to the side here, 4 to the 4th power means 4 times 4 times 4 times 4. So you are welcome to work that out by hand or use your calculator, and you would do 4 either y to the x, or it could be x to the y, depending on which calculator you're using, and then your exponent. So this is your base that you type in first, and then your exponent after you use that key. Okay, and after you work that out, you get a fairly large number. You get 256. So that's what I'm working out over here. So I have 4, and you can use the parentheses to show multiplication, or you can switch it to that traditional times symbol, whichever. So I have 4 times 4 minus 256. So at this point, I can do 4 times 4, which is 16 minus 256. Again, I've given you some negative numbers for your answers here. Don't be necessarily scared of them. So 16 minus 256 is going to give you negative 240. So that's what you would have in the answer blank. So this did have replacement value, which most people did okay with, unless maybe you switched the n and the y value. The big thing here was focusing on the exponent. All right, number 10 is the last one I'm doing, and a lot of people had a hard time with this. And again, it actually kind of came down to either really the absolute value and making sure that you do everything with that properly, or the square root. So those were really the two things that kind of tripped people up the most. So just again, since this is a fraction, you solve the numerator and denominator separately. So in the numerator, I have the square root of c, which I'm going to go ahead and do that substitution now, was negative 7 plus 32. This minus 1 is not under the radical sign. It is outside of it. So I am going to subtract that 1 after I deal with everything under the radical. So if I do the math here, negative 7 plus 32 that's under the radical sign, that's going to give me 25. So I'm taking the square root of 25, and then I'm subtracting 1 from it. I'm not going to take the square root of 24 or anything like that. So the square root of 25, of course, is 5, and then I subtract 1 from that. So that gives me a numerator of 4. In this problem, I actually did give you a place to write the numerator and denominator separately as you solve this. Okay, moving on to the denominator. This is where it dealt with the absolute value. So I had the absolute value of g, which is negative 3, minus 1. So in here, you are going to subtract first, right, before I can take the absolute value of whatever that is. So negative 3 minus 1 would give me negative 4. But I'm still taking the absolute value of this, and the absolute value of negative 4 is 4. So you should have had 4 over 4, which would give you a final answer of 1. One of the more common mistakes, if you did not make a mistake with the square root and recognizing that the minus 1 was separate, a lot of people forgot to take the square root of that negative 4 to make it positive. So these were just kind of a few areas that I noticed we kind of struggled with last week. I'm actually going over those problems, so if that was a question you missed, you can see what kind of how to solve that problem if you didn't understand any notes that I left you. And then the questions that you're going to be practicing today on IXL, we're kind of going back to IXL. We've taken a break from it because we've already done so much on it throughout the year, but there were a couple topics that you can still work on that would hit up these two areas of really that grouping and the exponents. So if you look at what I have for today, the first assignment is 7th grade as normal, right? It's I-9, which is evaluating expressions involving exponents, of course, up to a SMART score of 80. But the second one is 8th grade, and it's V7. This is dealing with absolute value. So if you open up IXL, 7th grade, I-9, I've started for you, is down here, evaluate numerical expressions involving exponents. Then you can either switch over to the 8th grade tab over here to find the next one, or it is listed, since I've started, it's under your recommendations as well, and you can, get to it that way. So it was V7 right here. So I've already started that for you. So those are the two that you're working on today. IXL you guys are pretty familiar with. But again, if you have any questions, feel free to send me an email and I can help you out. All right. Have a good day.